Καταρχήν, θα ήθελα να ευχαριστήσω τον Διευθυντή Ερευνών του Γεωδυναμικού Ινστιτούτου του Εθνικού Αστεροσκοπείου Αθηνών, Δ. Γεράσιμο Παπαδόπουλο, και τον Πρόεδρο του Οργανισμού Αντισυσμικής Προστασίας, καθηγητή Δυναμικής Τεκτονικής Εφαρμοσμένης Γεωλογίας και Διαχείρισης Φυσικών Καταστροφών του ΕΚΠΑ, Ευθύμιο Λέκα, αλλά και όλους όσοι συμμετείχαν στη διοργάνωση μιας τόσο επιτυχημένης εκδήλωσης. Συγχαρητήρια λοιπόν σε όλη την ομάδα. Συνεχίζουμε με την παρουσίαση στα αγγλικά. Dear attendants, let's share some ideas on how to contribute to improving resilience against earthquake risks by improving the operational capacity of civil protection authorities and the public response during earthquake emergencies. A sequence of actions during an emergency goes like shown in the scheme. First, we need to recognize the threat, assess the situation, analyze issues, consider alternatives, plan ahead, find potential solutions, assess potential blocks or problems preventing this solution of being efficient, make the decision and act, evaluate, reconsider, and so on. A crisis or a critical situation is related to some specific parameters which define a suddenly occurred threat. It is unexpected, it's a surprising event. There's uncertainty linked to it, and there's urgency. Urgency means or defines the necessity for specific actions which must be taken within a very constrained amount of time. Given that decisions are binary, we either do this or that, in order to make the right decisions, which are the efficient decisions, usually are the well-informed decisions, and in this way reduce the possibility of mistakes, we need complete and accurate information as about what has happened, where it has happened, who is affected, and so on. Earthquakes are unpredictable and sometimes catastrophic phenomena, so they incorporate the factors of threat or danger and surprise, and uncertainty is imposed by both the characteristics of the event and by the broad spectrum and variability of existing structural components and therefore characteristics of modern societies. Time is a key factor under critical conditions, and thus it is very interesting to note that in respect to time, according to Bauman, what is important is the speed and not the duration. Time during critical conditions represents a volume or space within which all actions related to overcoming the crisis must be taken, which means that time within a crisis can be considered as a quantity which can be compressed or expanded, depending on the speed and efficiency of the decisions made and the actions taken to overcome the situation. So, speed of making decisions and efficiency of actions taken is what is needed to mitigate the threat. Earthquake-imposed crises involve the entire community, including all of its structural components, the operational capacity of services, their response efficiency, and the respective response of the population. Especially the latter is strongly related to the level of communication, of comprehending the situation, and of being trained to respond. And we must also keep in mind that a crisis situation or a critical situation is related to the viewpoint of the one who is undergoing it, which means that different people may have a different perspective on the same critical situation. But on the other hand, decisions to be made in order to be efficient need also to be aligned among all involved parties, from authorities to exposed people. And both speed and efficiency can be continuously improved by planning prevention, preparedness, and response actions involving all stakeholders to ensure informed decision-making, high level of training, efficient coordination, and proper reactions. During earthquake-imposed emergencies, the crisis management structures need to know what has happened, where it has happened, the location, the extent of the damage, assets affected, lives at risk, and so on. In other words, they need situation awareness. Once the problems have been identified, then they can prioritize actions, allocate resources, and finally intervene, dispatch forces to respond to the problems according to existing protocols. And we should always keep in mind that except from the civil protection services and state authorities, the public can play a key role in the process of mitigating disaster risks. Having said that, the public also needs to have situation awareness, and even more, it needs the capabilities to comprehend the risks. Response capacity of the population can be improved if the necessary education and training is provided in a simple and comprehensible way, and also tools are provided to disseminate reliable information during those critical moments. With those conditions fulfilled, all involved are expected to have an improved behavior during emergencies in line with state emergency. And here is where these principles come to life over a proposed decision supporting system, which is being developed in the context of a project called Rapid Earthquake Damage Assessment Consortium, or REDACt for short. The project aims at exactly those targets. First, to support informed decisions regarding planning for both prevention and preparedness. Secondly, to provide situational awareness during earthquake-imposed emergencies, improving in this way response capacity, decision-making speed, and intervention efficiency. And at the same time, it focuses also to improving public response, always in line with state emergency plans. In order to overall improve emergency response efficiency and community resilience against earthquake-imposed risks. The way to do it is by developing a rapid earthquake damage assessment system, a REDAS, consisting of a platform, a smartphone app, and an educational hub. The REDA platform will provide damage level, and at this point as damage we mean the building stock, infrastructure, and geotechnical failures including landslides and liquefactions which can seriously affect safety. So it will provide damage level in the case of scenarios, helping in this way for both earthquake disaster prevention and preparedness planning. It will provide damage level near real time by processing real-time data from the combined existing monitoring networks. And it will cover all areas, including cross-border ones, where, for instance, ground motion parameters will be calculated, taking into consideration measurements from all sides of the borders, improving in this way calculation speed and accuracy. To improve public response capacity, the project will contribute to efforts already made by numerous existing institutions and state civil protection authorities by, first of all, developing a smartphone app to provide guidance and best practices to the public and improve awareness and response capacity, to give the public the ability of providing feedback and reports during an emergency situation, and to provide to the public important information during a crisis, including the on-demand location of persons of interest, family members, for instance. And at the same time, by developing an educational hub which will provide guidelines and tutorials to help the public develop their own emergency plans at various levels, at personal, family levels, always in line with state emergency plans. A brief look at the existing monitoring network which will be available for the REDA system, and we also see one of the low-cost accelerometers which will be used to make the monitoring network more dense in areas of interest. The monitoring network maintained by the Institute of Engineering, Seismology and Earthquake Engineering, ITSAC, in Thessaloniki will be combined with the monitoring networks of the National Institute of Earth Physics in Romania and AFAD Turkey, who are not partners in this effort, but they are major stakeholders and great supporters, and we are deeply thankful for their precious support. I will not provide technical details regarding the operational parameters of the REDA platform, since there will be a presentation by ITSAC Research Director Dr. Nikos Theodolidis regarding those issues, but I will point out that accuracy improvements on calculating ground motion parameters by using low-cost accelerometers to make more dense the monitoring network will be incorporated into the system, and also that harmonization was the great obstacle we had to overcome, and we did. The same stands for landslide hazard and liquefaction potential assessments. Details will be provided in another presentation by Professor Nikos Klimis, but geotechnical hazard assessment methodologies with the potential to provide accurate and reliable outputs were adopted in order to be incorporated into the REDA system. But let's focus a bit on the population. Which are the main concerns the population faces during an earthquake-induced crisis? How should the population react? Do's and don'ts. For instance, do not stream video over the internet. Prefer using data for communication like Viber, Messenger, WhatsApp, and so on over phone calls. The public also needs situation awareness, and even more, it needs the capability to comprehend the risks, but at the same time, they need to know where persons of their interest are, if they are safe. So they also need what has happened, where it has happened, who is affected, especially regarding people and assets they care about. Where to find shelter, primarily to places defined by the authorities, but also to places located individually. Routing towards those places needs also to be defined, considering exposure minimization criteria, which is the safest way to get there, for instance. And REDACt will contribute to this part by developing the smartphone app I mentioned, which will facilitate a two-way communication with the system and will also provide on-demand communication between user-created groups like families, friends, and so on. Obviously, training is needed to use the app and also to better comprehend the emergency situation. And here's where the Educational Hub comes into as an additional major output of the project. The REDACt Educational Hub aims at contributing to the plethora of existing material towards providing the required education and training to raise public awareness and help the population to improve their emergency response capacity, to better coordinate with the authorities, and thus to improve the overall emergency response efficiency and, of course, public safety. Educational material and indicative list is shown in this slide, will be produced. Electronic lessons targeted at experts and staff of the administration will include detailed information on REDAS and its efficient use to improve emergency response, whereas towards the less expert, let's say, part of the group, population, volunteers, and so on, popularized principles and guidelines to support the development of their own emergency response plans at various levels, with the assistance, of course, of the smartphone app, and the REDACt website will be developed. A few words about the project itself. Implementation is being financially supported by the Black Sea Basin Joint Operational Program 2014-2020 over the Rapid Earthquake Damage Assessment Consortium with the acronym REDACT project. The budget is very near to €1 million. The project will be completed at the end of 2022. Partners include the International Hellenic University as lead beneficiary, the Institute of Engineering, Seismology and Earthquake Engineering based in Thessaloniki, Greece, Demokritos University of Thrace, Xanthi, Greece, Gebze Technical University in Kocaeli, Turkey, Ovidius University in Constanța, Romania, and the Institute of Geology and Seismology in Chisinau, Moldova. Please visit the project website for more info, including video presentations and project deliverables. You may also use it to communicate with the project team. Thank you for your attention. Thank you.